Hello guys, welcome to the channel Understanding.Concepts.Of.Physics. Hope you all are doing well. In case you are a new visitor on this channel, then please do subscribe the channel and just follow the previous videos in order to get the best knowledge out of the channel. Okay, so we are continuing with our kinetic theory of gases, and today we will be doing only one, that is Kirchhoff's law of heat radiation. And in the next video we will be finishing Stephen-Boltzmann's law of radiation. So Kirchhoff's law of radiation, it's a very simple law, it's a very easy law, it's a very small in formula, and the proof is also very easy to understand. Okay, so Kirchhoff's law of heat radiation is written in two ways. There are two ways to write. The one is pretty easy, that it states that the coefficient of absorption, that is A, of a body is equal to the coefficient of emission, that is E. So a very simple law, that is A is equal to E. That's what Kirchhoff's law of heat radiation is. Coefficient of absorption is equal to coefficient of emission. Now there is another way of stating this Kirchhoff's law, and which says something like this. It states that the ratio, that means upon, it means that there is something in the ratio, there is something upon, of emissive power of an ordinary body. Now emissive power of an ordinary body is written as E, and it's the ratio, so that's why it is upon ordinary body to the coefficient of absorption, that means E upon coefficient of absorption is written as A, is a constant, and that value is coming out to be emissive power of a perfectly black body. So this is what is the second statement of Kirchhoff's law, that is emissive power of an ordinary body and coefficient of absorption. If you take the ratio, then you get emissive power of a perfectly black body. So ratio of emissive power of an ordinary body to the coefficient of absorption is equal to the emissive power of a perfectly black body. Now we are going to prove this, both the equations. So here, if you can see the diagram on your screen, we have a temperature enclosure. So we have a container which is insulated. So this part is insulated part. Now what does this insulation does? It does not allow the heat radiation to go in or come out. Okay, so it's basically a temperature enclosure. I just missed a cap on the T. Okay, it's a temperature enclosure. So you can see that heat will never flow out of and never flow into the heat. Now there is a black body kept over here, and there is an ordinary body kept over here, representing as B and O. Now B is also going to emit heat, and ordinary body is also going to emit heat. As we know in Prevost theory, every body at any given temperature emits as well as absorbs heat radiation. In case you haven't known about Prevost theory, I would suggest you just go back one video previous of this in this playlist, and you would find Prevost theory. Okay, so this is the insulating material, this is the temperature enclosure. B is the perfectly black body, so this is a perfectly black body. There is an ordinary body, this is an ordinary body. Now EB stands for the emissive power of a perfectly black body. So EB stands for the emissive power of a perfectly black body, and E stands for the emissive power of an ordinary body. So if you see, EB is for black body and E is for emissive power. Now again, emissive power was discussed in one of the previous videos. You can go back to one of the videos where emissive power is described. All videos are linked, so I would suggest you watch from the beginning to the end. And B and O are in thermal equilibrium. So B and O are in thermal equilibrium. So as soon as you put those two bodies in the temperature enclosure, they might be having a different temperatures, but after some time they are going to have the same temperature. Okay, so that's what thermal equilibrium means. Now I'm using the Prevost theory, and using Prevost theory I can say that the for an ordinary body I'm going to do, and for a perfectly black body I'm starting. Okay, so What does Prevost theory says? Prevost theory says that at any given temperature a body emits as well as absorbs heat energy, but at thermal equilibrium the rate of absorption and rate of emission becomes equal. So rate of absorption and rate of emission becomes equal. So for an ordinary body, how are we going to write? QA is the amount of heat energy absorbed, because you know that if a body is taken and this body is going to absorb, if Q amount of heat energy is incident on it, QA is the amount of heat energy absorbed, QR is reflected, and QT is transmitted. So if Q amount of heat energy is incident on an ordinary body, it is not going to absorb Q, it is going to absorb only QA, that is QA is the amount of heat energy absorbed. And E stands for the emissive power, that means the amount of heat energy it is going to emit. So QA is basically equal to E for an ordinary body. And for a perfectly black body, if you see, if this is a perfectly black body, if Q is the amount of heat energy incident on it, then it is going to absorb Q amount of energy. It's not going to reflect, it's not going to transmit, because it's a perfectly black body. Because it's a perfectly black body, it is going to absorb all the heat radiation. So EB, that is the emissive power of a black body, and Q is the amount of heat energy absorbed. So to conclude with, QA is the amount of heat energy absorbed by an ordinary body, and E is the emissive power, which is the amount of heat energy emitted by a perfectly black body, and that is equal because of Prevost theory. And for a perfectly black body, Q is the amount of heat energy incident, and that is also absorbed itself, because nothing is reflected and nothing is transmitted. And EB stands for the emissive power of a perfectly black body. Now you just have to divide these two equations. If you divide this equation and this equation, E upon EB, so I'll get E upon EB is equal to QA upon Q. So QA upon Q is nothing but coefficient of absorption, and E upon EB remains as it is. Now just move this on the other side, A comes here, EB comes there, so you get E upon A is equal to EB. That is the ratio of emissive power of an ordinary body to the coefficient of absorption is emissive power of a perfectly black body. This is one statement which we derived, and if you just see from this equation, this particular equation, I can also find out A is equal to E very simply. Now E upon EB is nothing but called as the emissivity. So if you can see this, E is the emissivity. So this is our emissivity. Emissivity is emissive power of an ordinary body to emissive power of a perfectly black body. Again, this was discussed in some other video. And QA upon Q is nothing but A. So E is equal to A. This is what is Kirchhoff's law. So Kirchhoff's law is very simple. Emissivity is equal to the coefficient of absorption, and this is what the proof is all about. I was about to also do the Stephen Boltzmann's law, but we'll be doing this in one of the other videos. So that's all for today. Thank you so much for watching. In case you haven't subscribed it, just please go ahead and subscribe the channel. And in case if you are not following my videos, I would really suggest that you follow all the other videos as well. It's a link, and if you just go one by one from the playlist, you will really follow the entire chapter. So thank you so much. Bye.